Okay, today we are going to actually be multiplying polynomials together. So we are on pages 19 and 20 in our notes. Okay, so we are looking for a handout that says multiplying polynomials. Okay. Aunt Barbara is sewing a rectangular blanket for her niece with the dimensions shown at the right. She wants to find the area of the blanket. Use the information to answer A through C. So we have the length being x plus 4 and the width being x plus 2. So Barb sets up the expression x plus 2 plus x plus 4 to find the area. Barb thinks the product will be x squared plus 8. Explain how Aunt Barbara may have found this expression for her area. Okay, well, if I look at this math problem, I see x times x. Well, x times x is x squared. And 4 times 2 is 8. So I think that's how she kind of did it. Okay. So we'll go ahead and see if she is right. So we're going to create just a model of this problem right here. So we are going to write x plus 4 right up here. Okay, and so I'm going to use algebra tiles. So we're going to use an x bar. And then we're going to use 4 little ones. Okay. All right, now I'm going to do x plus 2 right here. So I'm going to put an x bar, and then I'm going to do 2 little ones as well. Okay. Now we are just going to multiply these together. So we're going to do x times x, which would create a square, and then x times 1, x times 1, x times 1, and x times 1 would create x bars. Okay. Now we're going to do 1 times x, which would create an x bar. Then 1 times 1, another 1 times 1, a 1 times 1, and a 1 times 1. Okay. Finally, we have 1 times x, which would create an x bar. 1 times 1, 1 times 1, 1 times 1, and 1 times 1. Okay, so in here we have the entire area of this rectangle. So to come up with our answer, I see 1 square, so I see x squared. Okay, I see 1, 2, 3, 4, 5, 6 x's. Okay, and I see 1, 2, 3, 4, 5, 6, 7, 8. Okay, did Aunt Barbara correctly find the area of the blanket? Well, when I compare her answer, x squared plus 8, to our answer, x squared plus 6x plus 8, it looks like she's kind of right. But it doesn't look like we could use her method because it looks like it's missing some of that middle stuff. It looks like it gives us the first part and the last part, but that middle stuff looks like what we're missing. Okay, so today we're going to be multiplying some binomials times binomials, trinomials, and so forth. So we have to figure out the way we can do this because it is pretty to make a picture, but again, it is time consuming. So for each term in the first polynomial is going to be distributed to each term in the second polynomial. So this is really just like a bunch of distributing, just something we've never seen before. After we've distributed, we will combine any like terms if needed. Okay, so on the front page, we just kind of like are drawing visuals, and then on the back page, we'll come up with a little bit quicker of a method. So this first one, we have this binomial x minus 5, which is being represented right here, and then x plus 3 being represented right here. So this is using the area model. So x times x would create a square. Okay, x times 3 would create 3x. Okay. X times negative 5 would become negative 5x. And then 3 times negative 5 would become negative 15. So we have these 4 terms. These are actually like terms, so we can combine those together and create negative 2x. So multiplying that together, we get x squared negative 2x, and negative 15. All right, for this one, we're going to create the area model together. 2x plus 1, so I'm going to put 2x right here. Or that's a 7, sorry. 2x plus 7, so I'm going to put 7 right there. We're going to multiply that by 3x minus 1. So I'm going to put 3x and then a negative 1 to represent that minus. Okay, now we are just going to multiply using our area model. 3x times 2x would become 6x squared. 3x times 7 would become 21x. Okay. Negative 1 times 2x would become negative 2x. And negative 1 times 7 is negative 7. Okay. I look for like terms. It looks like these are like terms. So we have 6x squared, negative 2x with 21x, which would create a positive 19x, and then minus 7. Okay. Now this one is asking us to create the model together. So I'm going to create a binomial times a binomial. So I'm going to create basically a 2 by 2 box. Okay. 3r squared minus 2, and then r minus 9. Okay. R times 3r squared. R squared with it times another r would be r cubed. R times negative 2 would become negative 2r. Okay. 3r squared times negative 9 would become negative 27r squared. And then negative 9 times negative 2 would become 18. Okay. Now we're going to look for like terms. None of these are actually like terms because we all have different exponents on our variable. So our answer is 3r to the third. I'm going to go in descending order. So minus 27r squared, minus 2r, and then plus 18. All right, so we are now going to talk about different methods that don't require the area model. This is a great visual to kind of just represent what we're doing. Okay, another way is using just these graphic organizers. So these just show various ways to do this. So another way to do distributing a binomial times another binomial would be to take the first term, just like with the last page, take the first term, x, and we're going to distribute that to the second set of parentheses. Okay, then we'll take the second term and do the same exact thing. Okay, so we're going to take x times negative 4x, which would become negative 4x squared. Then we'll do x times negative 5, which is negative 5x. So I just took this one term and I'm distributing it to the parentheses. Okay. Now I'm going to take this term and I'm going to distribute it to the parentheses as well. 6 times negative 4x, which is negative 24x. And then 6 times negative 5, which is negative 30. Okay. Now I'm going to see if we can combine like terms. So I can combine my x's together. So simplified, this is negative 4x squared minus 29x minus 30. Okay, so that is one method to do this without creating an area model. My preferred method is actually just thinking of this as distributing, and I just think of it as distributing multiple times. So what I do is I take 2x and I distribute it to the second set of parentheses. So 2x times x would become 2x squared. Okay? Then 2x times negative 7 would become negative 14x. Okay? After I've distributed the 2x to both things, now I'm going to distribute the next term, which is the 5. So I'm going to do 5 times x, which is 5x. And then I'm going to do 5 times negative 7, which is negative 35. Finally, I'm going to combine like terms. So looks like those can be combined. And that would create negative 9x. So my answer is 2x squared minus 9x minus 35. Okay? Both methods are great methods. The area model is also a great visual method. So you just kind of got to pick which method you prefer. Okay. So for this one, I'm going to show you guys both different ways. Okay. So if you pick the first method, we're going to distribute the first term. Okay. We're going to distribute that Okay, so negative x times negative 5x, which would become 5x squared. Okay. Negative x times 8x would become negative 8x. Okay. Now I'm going to distribute the second term and multiply that to our second set of parentheses. 11 times negative 5x is negative 55x. 11 times 8 is 88. Now I'm going to combine like terms. I have 5x squared minus 63x plus 88. Okay. My preferred method is just to do double distribution, which it doesn't matter. You can pick whichever method you like. Okay. So I'm going to do 6 times negative 3y and get negative 18y. Then I'm going to do 6 times 10 and get 60. Okay. Then I'm going to do the second term, 7y times negative 3y, and do negative 21y squared. 7y times 10, which is 70y. Okay. Now I'm going to see if I can combine anything. It looks like I can combine my y's. Now when I rewrite this, I'm going to rewrite it in standard form. So I'm going to start with the highest exponent. Negative 18y, 70y, which would become positive 52y, and then plus 60. Okay, number 6 is something that's completely different than what we've done. It is a binomial times a trinomial. So again, it's the same process. That's why I like just simplifying, because it's always the same process for the most part. We are just going to do it 3 times. So I'm going to multiply or distribute the x to x squared. I'm going to distribute the x to the negative 3x. Oh, x times x squared is x to the third, sorry. Okay. X times negative 3x is negative 3x squared. And then x times 4 is 4x. Okay. Now I'm going to distribute the second term. 2 times x, which is 2x squared. 2 times negative 3x, which is negative 6x. And then 2 times 4, which is 8. Okay. Now I just have to look for like terms to see if I can add anything. So I see x to the third. Nothing can be put with that. I see some x squareds. Negative 3x squared and 2x squared, which would make negative 1x squared. I see 4 x's. Negative 6 x's, which would make negative 2 x's, and then the lone 8 at the end. Okay, so I want you guys to go ahead and try this one, and then you guys will check and see if you got it right. All right, so for this one, we are just doing distributing a bunch of times. So negative 6h, negative 3h would become 18h squared. Negative 6h times 2, negative 12h. Okay. Now I'm going to do 5h squared times negative 3h, which would be negative 15h to the third. 5h to the second times 2, which would be 10h to the second. Then we're going to do 4 times negative 3h and 4 times 2. Okay. So our highest variable, or exponent, excuse me, is negative 15h to the third. H to the second, 10 and 18, which would make 28. Regular h's, negative 8, 12, negative 12. And a lone 8. Okay. This last problem. Carla's painting rectangular skyscrapers backdrops to use her high school musical. The dimensions are shown for each. Use the information to find the answers A through C. So find the area of the larger skyscraper. So this larger thing has a width of 3x minus 4 and a length of 5x plus 12. So to find the area, we would have to multiply the length and the width together. Okay, So I'm going to do 3x times 5x, get 15x squared. 3x times 12 and get 36x. Negative 4 times 5 and get negative 20x. And negative 4 times 12 and get negative 48. Now I'm going to combine like terms. And my area for the large skyscraper is 15x squared plus 16x minus 48. Okay. B says to find the area of the smaller skyscraper. So smaller skyscraper has dimensions x minus 8 and 2x minus 3. Oops. X times 2x is 2x squared. X times 3, negative 3 is negative 3x. Negative 8 times 2x is negative 24x. And negative 8 times negative 8 times 2x is negative 16x. And then negative 8 times negative 3 is positive 24. Okay. Now I'm going to combine like terms, and the smaller skyscraper would be 2x squared minus 19x plus 24. All right. Final question is, find the total area that Carla would have to paint. So we would have to find the total, which means we would have to add like terms. Okay. So we would get our x squareds together, 17x squared. 16x, negative 19x would be negative 3x. Negative 48, positive 24, which would be negative 24. So the total area would be 17x squared minus 3x minus 24.